All right, well, I trust you did well on your quiz. Students in here, some of them felt like they did really well. Michael felt like he did well.
Yes.
I don't know about the other Michael, but this Michael felt strong. All right, take your homework out. Books open to page 186. Page 186. And page 186 to 187, you did 2 through 38, the even teal. We were talking about functions, and I said that in a function, you can't always plug in whatever you want. For instance, on the quiz just now, right, there was maybe a function f of x, and I said find, for instance, f of 7. Well, you can't just make up f of whatever. There are certain functions that certain times you can't plug in anything you want. What term from yesterday describes all the values you are able to plug into a function? All the values you can plug in for x or for the independent variable. Anyone? The domain. The domain refers to everything you can plug in. So class, what I'm allowed to plug in we call the domain. Now, what I get out of the function, there are sometimes certain limitations on what I'll actually get from the function. We referenced earlier from the homework, there was that graph, right, of that horizontal line. It said no matter what you plug in, you're always just going to get 3, right? No matter what x you try to plug in, it's a constant function. There's a limitation on what you get out. What you get out, class, is called the range. So what you plug in, and what you plug in, but what you get out, range. Got it? Good. All right. Now, another way you'll see this a lot of times in math text is all possible x values is domain, all possible y values is range. Because what you plug in is generally x, or thought of in terms of the x, the dependent variable. What you get out, the f of x, is the y, or the range. So let's see how we did on 2 through 38 even teal problems. Number 2, what limiting trait do we see on number 2, Audrey? Exactly. There are no limiting traits. And if there are no limiting traits we see, then we assume the domain is, and we assume the range is. All real numbers. That's what we should have had for both domain and range, was all real numbers. Somebody had that for number 2? Number 4, what limiting trait do we see? Michael?
None.
Did I say number?
Oh, wait.
Number 6 is what I should have said. I don't know what number I said. Number 6, let's try that one.
Constant.
It's a constant function, so there's my limitation. Now, as far as what I can plug in, my domain,
Everything.
all real numbers. The range,
Negative 11 to negative 11.
negative 11 to negative 11 in brackets. Just that one value is all you'll ever get. Number 10, the domain of the function is what, Kendall?
All real numbers.
I can plug anything I want in for x. That's my domain. But the range, what I get out, will be what? Now careful, that absolute value of x can only spit out what kind of numbers? Positives or negatives? Positives. So positive means 0 to infinity. But then we're going to subtract 3 from that, so negative 3 up to infinity. Does that make sense? All right, on an absolute value. Now on number 14, we see something a little different. Here, Maddie, the domain, still all real numbers. You can still plug anything you want in for x, but this time, that absolute value can only spit out negatives. Technically, it spits out positives, but it's multiplied by that negative in front. So it only spits out negative infinity up to 0, but then we're going to add 13 to all of that, so we end up with... okay, so you kind of did the flip side of what Kendall did. Because of the negative in front of the absolute value, it's going to go negative infinity up to 0. And then we're just going to shift it 13 units more. It's still starting at, but it's going to come up not to 0, but all the way up to 13 now, because we added 13 to our range. Does that make sense? All right. Number 16. What type of function is this, Abby?
It's a quadratic.
It's a quadratic function. And the quadratic function always graphs as what unique shape? Genesis? A parabola, that U-shaped thing. Now, I say U-shaped. It could also be an N shape, right? It depends on the x squared. But in number 16, my x squared is positive. So that means the parabola is going to go back to Abby upward. So it's going to be an upward parabola. That means the vertex is the lowest point. Now, the domain of a quadratic function is, you can plug in anything you want. But what it's going to spit out are values that start at the vertex and go up from there. So, what's my range?
1 to infinity.
Good. On the vertex, you're specifically looking at the y value, or the f of x value, because that's what you're getting out of the function. We're going to go 1 up to infinity on the y-axis, or f of x axis. Good. Whereas on number 20, now the x squared is negative. So instead of an upward parabola, it's a downward parabola. The domain of the function genesis on number 20 Number 20, the domain. All real numbers. Again, it's a quadratic. You can plug in anything you want. But what you're going to get out of the function will be...
I have negative 40 to...
Well, that would be if it went up, right? You would start negative 40 and go up to infinity. But this has a negative in front of the x squared, so it's going down. So you're going to start down at and come up to the vertex at negative 40. So negative infinity up to the negative 40. Remember, always parentheses on the negative infinity or positive infinity. But the value itself gets the bracket. So it's going to be parenthesis, negative infinity, comma, negative 40 bracket. Number 22, we have an even root. We have a radical function. And as far as the domain, this is the first function where the domain is limited because you can't have what kind of value inside the radicand class. Can't have negatives. So your radicand has to be at least 0 or bigger, 0 or positive. Well, what number is the kind of the magic number that would give you a 0 inside the radicand class? A 4, because it's got the negative already, so negative 4, positive 4 would give you a 0. Here's the question. Could you plug in a negative 5?
Yes.
I mean, could you plug in a 5 rather?
No.
Or a 6?
No.
Or a 7? No, because of that negative. But you could plug in a 3, 2, 1, 0, or really any of the negatives, right? So what is the domain? If we think through it that way, what's the domain on number 22? Michael?
5 to infinity.
I'm sorry?
I did 5. Am I on 20? No, I'm on 20.
Number 22.
I was on 24. 4 to infinity.
Well, you can't plug in bigger than a 4, though. For instance, you plug in a 10 there, that's negative 10 plus 4 gives you a negative 6. So not 4 and bigger, but 4 and smaller, or we would say...
Negative infinity to 4.
All right, and again, the other way you could do it, if you want to be more mathy about it, is you take the radicand and you say, look, this has got to be bigger than or equal to 0. And then if you wanted to, you could move the 4 over. The why you want to do it that way, I'm not sure. Get a negative 4. You could divide away the negative, which flips the inequality. X is less than or equal to 4, and that might help you see the negative infinity up to 4. But again, logically speaking, I can plug in a 4, 3, 2, 1, 0, negative 1, negative 3, negative 3, but I can't plug in 5, 6, 7, or 8. Does that make sense? Maybe that's an easier way rather than having to do the mathy way. That's the domain. Negative infinity to 4 with the bracket on the 4. But what about the range? Because remember, this radical can only spit out what kinds of numbers, Abby? On number 22.
Positive.
It can only spit out positives or 0 to infinity. And then we're going to subtract 10 from that. So what's my range?
It is negative 10 to infinity.
Negative 10 to infinity is correct. Anyone perfect on 22? You got both parts. Okay, Brandon. Oh, Abby got it as well. Okay, Genesis. All right, those who did it, does it make sense now? Again, I think the ranges we have a pretty good grasp of. The domains are the weirder ones because there's only 2 things that'll ever mess with your domain. Does it make sense now? Let's look at a similar problem here in 24. What's the magic number in 24, Maddie? On 24, the number that just gives you that 0 inside. A negative 5 would give me a negative 10, right? A positive 5, right? What if I went bigger than 5? What if I said 6? Is that okay? Can you do 6 minus 5? Yep. 7 minus 5, 8, 9, 10. But you can't go 4 minus 5, can you? So that means our domain must be 5 to infinity with the bracket on the 5. Now, as far as the range, what kind of values will that radical always spit out, Kendall?
Negative.
Negatives. In other words,
Negative infinity.
up to the 0, right, would be negatives. But then we're going to add 8 to that. So what's my range now?
Negative infinity to 8.
There we go, negative infinity up to 8. Did anyone get that on 24? I'm going to assume the same people. All right, those who missed it, now that we've done a couple of these, making more sense to you. All right, number 26. Maybe redo this quickly and call it when you think you're ready for it, but we're going to go to Genesis. What is the domain? But you can't plug anything in there, right? I can't just make up whatever I want, because then I might end up taking the square root of a negative, and I can't have negatives in there. In fact, what is my magic number on 26? As the rest of you are reworking this also. -6. What if I went bigger, like -5? Is -5 cool? -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, all the way up to infinity, right? But I can't do -7, can I? So how would I describe my domain? Start at -6 and get bigger. So we would say -6, -6 to positive infinity. That's my domain, with a bracket on the -6 and the parenthesis on the infinity. What about the range? What kind of values does that radical spit out, Genesis? Positives. And then we're going to add 18 to all of those positives. So how would I describe my range? My range. You said the radical is going to spit out positives, right? By definition of Genesis, positives are numbers that start at 0 and go up to infinity, right? But then we're going to add 8 to all of it, which just shifts the arrow that way. So what's my range? There we go, +8 to infinity. Does that make sense? All right, anyone have both of those correct already? Anyone get it before she did when you had to redo it? You had to correct it and you figured that out, all right? Feel like we're understanding the radicals. I felt like we were cruising until we hit radicals. It was like, whoa, what's going on here? All right, feel like we got it now. All right, let's go on to the rational ones, the fractions. Really two things to remember about fractions. First of all, as far as what you can plug in, you cannot make the denominator class equal 0. And the denominator, a number 32, would equal 0 if you plugged in what number? -2. So for my domain on number, did I say 32? Yeah, on 32, we get all real numbers except -2. I can plug anything else in for the x except -2. Now, as far as the range goes, this was a weirder one, because we're good with denominator can equal 0. We've seen that before. The range was weird. What's the rule about the range of our rational functions?
Can't be the leading coefficient.
The f of x will never end up equaling the ratio of the leading coefficients. It just can't. There's no way mathematically to make that happen. So on number 32, the two leading coefficients are 1 and 1. So my f of x can be anything except a +1. It's never going to end up equaling that. Again, it's not that you can't plug that in. It's you can't ever get that out. You can't ever plug that in. You'll never get that out. So on number 38, this one's got a weird domain value. What's my domain here on 38, Brandon? All real numbers except 13/8. And then what about my f of x, my range? What do we have here, Michael?
All real numbers except 1.
All real numbers except 1. Can't get a 1. Questions on those? I'm not even going to ask if you got them all right, because I really don't care. What I care more about is, do we understand them better now that we tried them ourselves, whether we succeeded or failed? Having tried them ourselves, having heard them explained, do we understand it better? I want you to go back now and hit all the non-teal evens. Do all the non-teal evens on 186 to 187. So all the skipped evens. Get the domain, get the range. doing all the non-teal evens, all the ones we skipped. Michael's got him. The real one. Just look at good posture, head off of hand. Allowing our brain to work at its peak as much as it can when you're dressed funny. I don't know if I've ever had a student try to take a quiz in a Musa Akuna Manada thingy outfit before. Banana has to. Never. Yeah, but it's M day, so banana's no good. It's gotta be M. Just about another minute, and then we're going to go over these. We'll probably go a little over time again today, but I want to make sure we've got this before we try the homework. For sake of time, pencils down. Check the ones you got done and try to follow along with the ones you did not finish. Number 4, you plug in anything, get out anything. Domain all real numbers, range all real numbers. Number 8, domain all real numbers, range 18 to 18 in brackets. Number 12, domain all real numbers, range 30 to infinity. Number 18, domain all real numbers, range, it's an up parabola, 11 to infinity, with the bracket, of course, on the 11. Number 28, domain, 4's the magic number. I can plug in bigger than a 4, not smaller, so we'll say 4 to infinity. The range is going to be 7 to infinity. Number 30, again, this time negative 3 is the magic number, but I can't go smaller. I can't do negative 4, negative 5, anything like that. So we'll say negative 3 to infinity is the domain, and 22 to infinity is the range. Stay with me, just got a couple more. 34, the domain is all real numbers except 5. Range is all real numbers except 3 over 1 or 3. Number 36, the domain is all real numbers except negative 4. The range is all real numbers except 4 over 1 or 4. Number 40, the domain is all real numbers except 4. The range is all real numbers except 5. Anyone perfect on all the ones you did? You nailed all the ones you got to. All right. Questions on any of those before we wrap up? Any of those, you say, can you please explain how you got that? It's still a little iffy. All right, you're going to practice with several of these in your homework tonight. Page 188, do 1 through 14, the teal. Page 188, 1 to 14, teal. Kind of a good review as we look ahead toward a test coming up in lesson 105. Okay, so we've got a test coming up, good review of some basic stuff we did a while back. Page 188, 1 to 14, teal, and page 189, do 29 to 38, all. Page 189, do 29 to 38, all. That's a set of those domain and range questions. We'll look at all of that tomorrow. Let's take a look at your quizzes tomorrow. And we're done with new material. Nothing new before Friday's test, so it's just reviewing these next 2 days to make sure we are ready for test 7 in lesson 105. Have a wonderful rest of your day, and you are dismissed.